Today we will discuss about magnetic field at the center of the circular coil carrying current. We will find the magnetic field at the center of the circular coil current carrying. If we consider a coil, center C, radius of coil is R. We consider a small element dl, current is flowing in the coil is I. The magnetic field due to small element dl at center is, find the Bio and Savart law, is dV equals to mu naught upon 4 pi I dl sin theta upon r square. If we consider the only magnitude of a magnetic field is dB, mu naught upon 4 pi, current I is the current flowing through the coil is I, small element dl, sin theta is angle between point and the small element. This angle is 90 degree. So sin theta is 90 degree upon distance between center and the element of length is r. That means this is r square. dB equals to mu naught upon 4 pi I dl upon r square. This is a magnetic field due to small element dl. If we consider all elements, we integrate the dV. Integrate both sides. Integration of dV is b equals to constant values are mu naught upon 4 pi I upon r square integration of d. Line integration of the circular coil element is 2 pi r, means b, we can say b equals to mu naught upon 4 pi upon r square into 2 pi r. R से b is mu naught upon 4 pi I 2 pi upon r. Cancel out pi to pi. Mu naught upon this is the magnitude of magnetic field at the center of coil. If number of turns in the coil is n, we will this is our final result. And we saw the direction of magnetic field with the help of right hand thumb rule. Means magnetic field around this conductor is circular path in the around the wire this direction. Also at the point C, magnetic field is inside the plane. Means B and direction of B is if we change the direction of current, direction of magnetic field is also inverse or is opposite direction, and in magnitude is remain constant. Next, magnetic field at a point on the axis of circular coil carrying current. Next heading, magnetic field. If we consider a loop, the radius of loop is r. If we consider a circular coil, O is the center of coil. At point P where we want to find magnetic field intensity, this is the circumference of this circle. If we join the circumference and the point P, this angle is also 90 degree and this is angle is also with 90 degree. We consider a small element dl at any point of circumference. Find the magnet current is flowing through a coil is magnitude is I. Magnetic field intensity at point P is dV equal to mu naught upon 4 pi I dl sin theta upon distance between P and dl element. If we consider R, means R square, where R square is equal to x square. X is distance between point and the center of the coil and A is the radius of the coil. Where dV, this angle is 90 degree. dV equals to mu naught I dl upon 4 pi r square. The direction of magnetic field is this direction. If we divide two components, horizontal component and vertical component, means that means this component and this angle phi, this angle also. This component is dV cos theta, this dV cos phi, and this component is dV. We consider another element same length dl opposite to the previous one element. Magnetic field, direction of magnetic field in this direction. These are also two components, this component and this component. Also dV cos theta and this is dV sin theta. Means dV cos theta is equal and opposite, so that there are cancel out, only remaining the dV sin theta component. So we can say dV, net dV equals to mu naught I upon 4 pi dl r square into sin theta, sin phi. So sin phi equals to perpendicular upon base, perpendicular upon hypotenuse. Perpendicular is A, hypotenuse is R. Means A upon root x square plus A square. A upon root A square A upon x square plus A square power 3 by 2 equal to dB. In this equation, variable is mu naught upon 4 pi is constant, I is also constant, A is the radius of circle is constant, x distance between point and center is also constant, only variable is dl. So we integrate the both side with respect to dx. Integration of dv is let b equals to mu naught upon 4 pi I a upon x square plus a square power 3 by 2 into integration of dl. Integration of dl is a whole circumference of the circle equal to 2 pi r, means b equal to mu naught upon 4 pi I a into 2 pi a upon x square plus a square power 3 by 2. B equals to mu naught upon 4 pi I a square into 2 pi x square plus a square power 3 by 2. The direction of magnetic field is cos component is cancelled out, only remaining this side of direction, means only by sine component of dB. We can say dB b equals to mu naught upon 4 pi 2 pi I a square upon x square plus a square power 3 by 2. If number of turns in the coil is n, so b will be mu naught upon 4 pi 2 pi n I a square upon x square plus a square power 3 by 2. The unit of magnetic field is Weber per meter square. This is our final result. The direction of magnetic field also we find the clock rule. If current is flowing through a coil, the coil is clockwise direction. And if we consider a coil, this current is flowing through a coil in clockwise direction. So this phase behave as a south pole. And if direction of current is anti-clockwise direction, behave as a north pole. In this derivation, if a person is standing on point P, current direction is, if clockwise, magnetic field is behave as a south pole, and anti-clockwise direction as a north pole. This rule is known as clock rule.